Hello everybody and welcome to this video where we're going to look at an exercise that deals with an elastic collision. So as we have seen from before, in elastic collisions, the idea is that when two objects collide with one another, they end up bouncing off of each other. And we have seen how the formula is a little bit different from the formula when we're dealing with inelastic collisions, where this is the form it looks like. So now let's look at this particular exercise. A moving 7 kilogram bowling ball elastically collides with another 9 kilogram bowling ball. So let's write this given down. First, we have the 7 kilogram bowling ball. This is MA. And we have a 9 kilogram bowling ball, MB. The first was moving to the right. Well, I'm glad I did it this way. With a speed of 1 meters per second. So let's write that down. VA is 1 meters per second. While the second one was moving at 1.4 meters per second. So this means VB is 1.4, but given that it's going to the left, it has to be negative 1.4 meters per second. Remember, we're taking the right direction as the positive, while everything to the left will have to be negative. Calculate the velocity of the second bowling ball while after the collision, knowing that the velocity of the first was negative 1.7 after the collision. So after the collision, MA stays the same. It is 7 kilograms, of course. But now the velocity of it, VA, is negative 1.7 meters per second, and we're going to write that as VA prime. Now, we know that MB stays the same. It is going to be 9 kilograms, but VB is the thing that's changing. So V prime B is our unknown. So let's start plugging in our numbers. We know that the momentum before the collision is equal to the momentum after the collision. So we expand both sides into MA VA plus MB VB, which is equal to MA VA prime plus MB VB prime. Now what we want is VB prime, so I'm going to color that differently. I'm going to keep it in red. I'm going to keep it in blue just to stay consistent. VB prime. We want VB prime to be isolated. So we're going to move everything around it. Right, so we're going to move everything that is annoying it to the other side. And to do so, I'm just going to add this little fraction line here because we're going to need it. And we're going to start moving everything to one side. So in fact, before I do so, let's move this entire thing, MA VA prime. So we're going to pick this thing up, move it to the other side, and now it's going to become negative. So to make space, I'm just going to move the entire thing. So MAVA prime goes to the other side, and it becomes a negative. Okay? So this is our first step. Easy enough. Next, we want to move MB to the other side because it is annoying our V prime B. So we're going to pick it up as well, MB, and move it to the other side. Given that this is multiplication, we're going to take it as a denominator on the other side. And this is what we're going to have. VB prime is equal to this entire thing. Now we're going to plug in our numbers. So VB prime is equal to, we're going to have our MA. MA is 7 kilograms times VA, which is 1 meters per second, plus MB, which is 9 kilograms, multiplied by VB, which we said is negative 1.4. It's right here. And minus MA, which again is 7, times VA prime, which is negative 1.7. and this is our numerator. The denominator is just mb, which is 9 kilograms. So you put this number on the calculator, and you're going to get 0.7 meters per second. And this value is positive, which means we are right in drawing the arrow to the right, because everything going to the right is positive. So v prime b ends up moving to the right at 0.7 meters per second. And this is the end of the question.